2.3 and 2.4, mathematical modeling and deductive reasoning. First term, math models. Okay, whenever we talk about math models, this is basically graphs or pictures of situations that you can use to describe a problem and maybe help you solve the pattern as well. You can also figure out equations, and equations are a type of mathematical model to help describe the problem as well, which you did back in Algebra 1. Physical objects that are examples of mathematical models, points, lines, planes, triangles, polygons, diagonals, maybe even any chart basically, maybe even like segments. We'll use segments here in a little bit, diagonals, and so on. We will use these, to also help solve problems as well. Okay, so the investigation that we're talking about here is a handshake, or the number of handshakes going on at a party, depending on how many people are there. So like a typical question would be, if there's 100 people at a party and all of them were to shake hands, how many handshakes total would there be? Okay, well you can start off by just doing simple numbers like this. If there's one person at the party, 0 handshakes would go on. If there's 2 people at the party, only 1. If there's 3 people at the party, then there would be 3. Okay? And you can use set points to figure that out. 1 handshake, 2 handshakes, 3 handshakes. If there's 4 people at the party, and we're going to elaborate on this here in a minute. They shake hands, 2, 3, 4, 5, and 6. 6 people shake hands. So this is using mathematical models there. By then, you might be able to figure out patterns. So let's erase this mark right here. And so looking here, it went up 1, went up 2, went up 3. So you already probably figured out the pattern that's going to go up by 4 of the same time. So if there's 5 people, 10 handshakes would go on. 5, 15 handshakes would go on at a party of 6. And 21 would go on at a party of 7. Okay, so the question is, well, what's the rule here, or the nth term, to figure out how many handshakes would go on for any number, or for in this case 30? Because I don't know what 30 is, and I don't really want to hurt it all the way to 30. So the next thing you can do is figure out the second differences. Well, at this point right here, you should know, based on your Algebra 1 skills, that this is not linear. Okay, and I know your teacher taught you to use stat, so you can't use a stat function until linear regression. However, on the second set of differences, it is constant. So at this point, when it comes out constant the second time, then that means that we're dealing with a quadratic function. Okay, and so you could technically use stat in the calculator to figure it out. So when you go to stat, okay, you would type in this table, and you would go to the stat function again and calculate the quadratic regression, because we're dealing with a quadratic relationship here. So when you do that, your function, I believe, comes out to 1/2 n squared minus 1/2 n. And so once you get that, you can figure out that if you plug in 30 to n, or if you plug the equation into y equals, you can go to the table and figure out what it would be for 30 people at a party. Okay? And it should come out to 924 handshakes. Okay? So use this rule once you figure it out to figure out the difficulty like that. Here's using math models, kind of like I started earlier, to figure out the problem. 2 people, 1 handshake. 3 handshakes. 4, 6 handshakes. Okay, so 1 handshake, 3, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 handshakes here. So party of 5, party of 4, party of 3, party of 2, party of 1, you have to say to yourself, well, how am I going to figure out this rule and this pattern? So you have to think of these as in the number of people, right? And then of course you know these are the number of handshakes. So it's got to be related to the number of handshakes each person has. So in this case, this person has one handshake each. One as a party of two. This one has one. This person has two and a party of three. They each shake hands twice. Okay? So they each have two handshakes. Over here, they each have three. And this one, they each have four. Okay, so that's got to be related to the rule here. Okay, so we want to multiply the number of people at this party probably times the number of their handshakes. Okay, so in this case, how is the 1 related to our n? How is this 2 related to our n? How is the 3 related to the n? How is the 4 related to the n? N again is the number of people. Well, they're all, if you figure out the pattern, they're all one less. Well, how do you write one less? You subtract one. Okay, so I'm going to subtract 1 from n. Okay, but then you have to say to yourself, well, if I total these out, this here came out to 6 total handshakes, which is not 3. This total handshakes came out to 2, which is not 3. I mean, not 1. 3 plus 3 plus 3 plus 3 came out to 12. That's not 5. And then 4 times 5, that's 20 total handshakes. Oh, that's 6. This one's supposed to be 6. Okay, and then that's 20. And so the total number of handshakes, which comes from this right here, to how's that related to that number, our actual number of handshakes? 6, 3, 12, 6, 20, and 10. Okay, so they all notice are double. So what we want to do with this rule here is cut it in half so that way it is the number of handshakes. Okay, because if we talk about these two, each having a handshake each, well, then we go back and talk about this person. Well, we already counted this handshake with this person here. So that's how the meaning of cutting it in half. So here's the rule another way. Another way to write that is the way we wrote it earlier. 1/2 n minus n squared, sorry, minus 1/2 n. Okay. Same thing that the calculator would do. Deductive reasoning. Deductive reasoning is the process of showing that certain statements follow logically from agreed upon assumptions and proven facts. So I would highlight that. Whenever you think of deductive reasoning, think of proof. Okay? You can think about also like lawyers in the real world. They always use deductive reasoning. Deductive reasoning again shows proof and it validates. It shows how your answer is valid, okay, or true. So that's why it says it in the second one. Okay? You're reasoning to the point where you're showing proof that your conclusion is true. Okay, so I'll give you an example of deductive reasoning here. So what is the difference between inductive and deductive? Inductive reasoning is used to make conjectures. Okay? And you have to remember back when we went over that, when we make a conjecture, and this is just kind of like a generalization. Who's to say whether it's true or not? We're just going based on past experiences or based on previous, trial and error. So this is just a generalization, or one sometimes I'll consider it this, like a guess, an educated guess. Okay, so there's really no proof that that's our answer, but we're just assuming that it is based on past experiences. However, deductive reasoning is used to verify conjectures. So this one shows actual proof that the answer is correct or it is what it is. Okay, so this one you have proof. Okay, you have valid reasoning behind your be able to determine the difference between the two. I said this a little while ago that the real world experience is lawyers use deductive reasoning, okay, to show evidence in the courtroom. In algebra, you can provide a reason for each step you take in the process for solving the equation. Here's another little investigation of what you can have deductive reasoning involved. It says each segment AB is congruent to CD, so let's mark those congruent. AB is congruent to CD. From the markings of each diagram, determine the lengths of AC and BD. So AC is here. BD is here. So what is AC now? It looks like it's going to be 100. Okay. What is BD? Well, these two are congruent. This is also going to be 100. Let's look at this case. AC. AC. Well, let's figure out BD first, since they gave us that one. First, BD is 116. Okay, well, 116 is over here, so that is also going to be 116. So based on this right here, we have actual proof because we tried it twice. Once with this segment, twice with this segment. If AB has points A, B, C, D in that order, then with AB or CD, what happened while the time is young? Well, AC was exactly the same as BD. AC was congruent to BD both times, and we have proof here. So there's a little example using deductive reasoning again. And here's another example which you need to use deductive reasoning. Okay, if I'm going to solve this algebraic function, okay, I'm going to get x equals an answer. And so what's the proof that that's the answer? Each step along the way. So like this first step that I'm going to take is to this property here. And minus 24 plus 16 equals 4x. So the reasoning for this line right here is the distributive property. I'm allowed to do that by using the distributive property. Okay? My next line that I would do is I would combine these like terms. Okay, so 10x minus 8 equals 4x plus 2. So my reasoning for that line, I could say the addition property or combine like terms. Okay, so I'll just write combine. My next line, I would probably want to put this 4x over here, which I still have to subtract it, so I get 6x minus 8 equals 2. So the reason for that line right there is the subtraction property. Okay. Now, next line, I would add 8 to get rid of that. So the next line would say 6x is equal to 10. My reason for that one is addition property. You see how I have a reason for every step along the way? And the last step to summarize is 5 by 6. And so x is equal to reduced 5 over 3, right? And I guess another way you could write that is 1 and 2/3. Either one of those answers is correct. But either way, the reason for our last final answer is what did we do last? Addition property. So I have proof on why x is 1 and 2/3. These are all my reasons right here on the right of why